Hey Sarah, are rasters monsters?
There's no such thing as a roster monster. Today, we're going to talk about what raster files are. Raster files are another way of working with GIS data. It is a way of storing your GIS data. Rasters are in the form of grid cells or pixels, and each pixel is associated with one attribute. And when we put all those pixels together, we end up oftentimes with pictures or maps.
Yeah. So if you think about it, just simply visualizing what a raster is. When you take a picture with your phone, a digital camera, what you're getting is a collection of pixels that each have a color attribute to them. When you take photos with your phone, you are making a raster file. And that's when we're talking about raster files in GIS. It's a very similar concept, the same kind of structure, but we're going to throw another piece of data into it, which is where it's located on the face of the earth.
When we're working with rasters, there are two types of raster files that exist. First of all, raster images. These are quite simply georeferenced pictures. Jodi just talked about, taking a picture with your phone and you've got all these pixels. And when you put all those pixels together, you get a picture. All we do is georeference them. Pretty simple. The attribute on this particular raster image is the color value itself. So when you see a picture, you've got a color value. And often when we're thinking about images, we're thinking about multiple bands of light that might be associated with the picture. For example, a normal picture probably has a red band, a green band, and a blue band of light associated at that one pixel. And that attributes to what the color is that we see with our human eyes. A raster image, when you think about this in precision agriculture, we can think about it from a standpoint of a NAPE image. Those FSA maps that are geo-referenced, we turn them on all the time in ADMS. They're very pretty pictures of the field and the landscape, very common. And common image raster file formats would include GeoTIFFs, JPEGs, SIDs.
And so the other type of rasters are raster grids. These are an even more simplified version of a raster. What do I mean by that? You have all these pixels, but there is only one value per pixel. How we get there to a raster grid is say, if you're working with a NAPE image that has these three bands of colors, the red, green, and blue. If we're, for example, in ADMS, using that software, what we would do is we would extract just the red band of that image so that when we're working with that specific raster grid, we're only looking at the red band of light from that raster image. So again, when we're working with a raster grid, we're working with just one value per pixel.
That's a great point, Jodi, that when you pull out that one band of light, you're getting that one value per pixel. But we can, quote unquote, rasterize other things too. For example, we can take a vector file, like a raw yield data coming out of a combine, and we can rasterize that. What we're doing is basically we're painting by number. We're taking that one value of that yield data and assign a color to that number and then paint that on our screen. And we're going to get a yield data map out of it.
We can take vector files or the drawings and maps and rasterize them and make them raster grids. And like Sarah mentioned, we're no longer relying on color information from an image to tell us how each of those pixels should be colored. We're now relying on that data to tell us how that map should be colored. So depending on whatever color theme we want, that's going to color how our final map looks like.
In ADMS, for example, quite frequently we use either a rainbow color scheme or we use a red, yellow, green color scheme. And we can use that on the same piece of yield data. It's going to look different because it's got a different color scheme associated with it. But nonetheless, we're just painting by number. And another important thing to think about when we're rasterizing vector data, vectors have a database that goes with it. They've got multiple attributes that get associated. In raster data, we only have one attribute associated with that location data. And so when we're rasterizing a vector file or a shape file often, we have to take a look at that database file and decide what column of that database we're going to rasterize. Often when we're getting, for example, yield data coming in from a combine, there might be yield data associated with that, moisture data associated with it, perhaps even maybe some elevation data. And you can rasterize all three of those attributes, but you're going to get three different maps. Common file formats for raster grids or surfaces include GRDs and bitmaps.
So one of the really cool things about working with rasters is that layers with the same resolution, so like 3 meters over 3 meters, those pixels represent the same area from one layer to the next, right? And so if you want to start doing math and comparisons, it's really easy to start doing that intra-layer math. And so that's why rasters are so great to work with when we think about working with GIS data, because we can then do this math and not have to worry about doing complicated equations to figure out how much of an area represents the other when we're layering them over the top of another.
That's a really good point, Jodi. And in ADMS software, for sure, the magic happens in the surface portion of the software. So when you open up your software in ADMS and you look on the right side of that software program, you see a drawings and map, a surfaces and map, and an images and map. The drawings and map, those are vector files. Okay. And we did talk about that in a different podcast another time. Totally worth tuning in for in case anybody was curious. But the categories that we're really talking about today with raster files are the bottom two, the surfaces and map and the images and map. The images and map, those are raster images. But once we have rasterized other data or pulled out those bands of light and made raster grids or surfaces, that's the category where the magic happens. And I've had this happen where a farmer will call up, he's got a prescription that's been made. He likes the prescription, but he just wants to add or subtract off certain pounds of fertilizer. So let's say all of a sudden he wants to add 50 pounds of urea or 25 pounds of urea. Well, it's really simple with a surface because there's one value per pixel. All you do is go in and hit the little calculator and say plus 25. And all of a sudden you've increased that across that one map. But like Jodi just said, it's also very easy to turn on multiple maps and do math across the layers of all the pixels because the pixels match up absolutely perfectly.
Like Sarah mentioned, when we're working with the raster grids, that surfaces and map area of ADMS, that is where the magic happens. And what I mean by that, it is so powerful to work with rasters, to do math, to do averages, to work on formulas, to come up with answers to the questions we're commonly asking in agriculture, or even putting together prescriptions that we want to make to help us really do the things we want to do.
Absolutely. And remember, all we're doing in there is coloring by number. If we want to just change something completely in a different area, all we have to do is change the number. As a matter of fact, it's very easy with rasters. You just draw a polygon or a shape around a certain area of a map and you select that area. And we even have a magic wand in there just to change the number to whatever you want it to be.
It is truly where the magic happens.
Very magical.
Not monsterish?
There's no monsters with rasters.
Like we said, rasters are incredibly powerful. They are not monsters, and they're a great way for us to bring power to data when we're working with precision agriculture.
It's a very powerful way of working with data. With that, at GK Technology,
we have a map
and an app for that.
Let the geeks at GK Technology help you with your agricultural data. Their agronomists know agriculture. When it comes to creating soils and zone maps to maximize yields in your fields, you can trust the people with decades of experience in site-specific agriculture. Everyone at GK Technology has a background in agriculture, so they know what makes a farm run, and they speak your language. The geeks at GK Technology have a map and an app for that.